Hey YouTube, welcome to our channel, the ultimate guide to ace your software interviews. If you are new here, make sure to subscribe and hit the notification bell so you'll never miss a video. Today we have this problem. It's a balanced binary tree. The problem goes given a binary tree, determine if it is height balanced, and we have this tree. It should be a height balance or not. I will describe in a minute what a height balance means actually. And if we had this tree, it's not height balance. So basically, let's go to our dashboard, or like to our board. So basically, in the tree, the left subtree has a height, like basically I'm saying here, if I had a tree that has goes like that, 5 and 3 and for example 1 and 4, and we have this one is 0. Sorry, it's not, it's a pretty bad 0 actually, 0. And we have the right side is 8. Let's make it 8, yeah. Okay, so basically what we have here, if the left side subtree, this subtree, okay, this left side subtree has a height of 2, basically 1 2, and the right subtree has a height of 0. Actually, it has no height. And basically the tree becomes not balanced when only when the difference between the left and the right is greater than 1. So basically we have 3 minus 0 equals 3. So basically it's a greater than 1. And yeah, this is not basically what we are looking for. So basically we want to know if it's balanced or not. So one of the things that we should create, maybe I'm also thinking about recursive. Look something about something. When we deal with trees or graphs, okay, we will deal a lot with the recursion basically. So basically, let's just look at this one. First, maybe we could create a recursive function to calculate the height. So basically, we start to calculate all of the height of the left and the height of the right. Let's just make this if we made, let's just make this tree. Yeah, okay, nice. No, I want to be in the middle. Yeah, okay, this is fine. So basically, we try to calculate the height and compare it to the left side and the right side to make sure that, and after that we just create another recursive function to call this recursive function again. Okay, it sounds quite weird, but let's just see how we can do it. So basically, we will have a function. First we have a function that called let's call it height, and this function takes a root or like a node or whatever it will be, and basically it calculates the height. That's it. So if I'm saying that, okay, we are doing a recursive function, each time we do a recursive function, what we should do, we should know the base case. The base case in my mind right now is that if I have no height, just don't loop again, return something. If no root, return -1. Okay, and I will say return 1 plus math.max. Okay, height of root dot left and height of root the right. So if we went here, we want to know the actual root. So basically, we want we go to this subtree, and we get first the height of the right tree, and the height of the right subtree, and the height of the left subtree. And what is the big for this one? We had it's for this one it's 2, 1. We take 2. That's it basically. And by the way, this subtree by its own, it's if you okay, I will say a question, and you can feel free to answer in the comment below. This subtree 3, 1, 0, and 4. Is it balanced or not? If you know the answer, just comment it down. And when you comment it, just put the description why you think this tree actually is balanced or not. And I will review your answer, and I'll just maybe give you a review. Maybe I will learn from your answer. Who knows, basically. So basically, we have a function that calculate the actual height. So basically, what we should do right now, we create another recursive function that call height, okay, and we say why. So basically, for this one also we will make a base case. I also think that it just only root, like if there is no root, return I guess return true, because if there is no root, because we will keep go right left. If you are in a position that there is no right and there is no left, that means yeah, it's quite balanced, because we will try to test each subtree basically. So I will say that, okay, if not root, return true, and I will say that return math dot absolute, and I will get the math dot absolute because I don't want to get any negative values. Height, okay, dot root dot left. So basically I'm getting all of the height of the left root, okay, minus height of root dot right, okay. And sorry, I got. And what we have said that it's that the minus between the left side height and the right side height should be shouldn't be bigger than 1. So I'll just be it's less than 2. If the right, it's true basically. And for this solution, we do it only on the tree, but we want to do it in all of the subtrees basically. So I will do this one on the left side also, and in the on the is balance, it will be root dot left, and I will call it again is balanced, will be root dot right. And yeah, I guess that's it. Let's see. Okay, that's the solution, but let's just talk about how this worked actually. So basically, if we know about the height, first of all, we create this height one, and it just to continue to call itself until we find no root. So basically, I'm starting first. I just want to know the height of the left one, so I'm just start for this node, and I have 1, and while I have 1, I am calculating the left and right. When I try to calculate the left and right, I'm calculating the left first. So I'm seeing that this one is the left is 1, so this will be 1. Okay, however the right is 2. Okay, so it's 2 plus 1, it will be basically it will return 2 basically, because I will have this root right. Basically, I'm calling it, and yeah, that's it. Basically, I'm calling it, and it returns the actual value for me, and yeah, that's it basically. And hope you like my solution.